And I think we're back. So, tonight I want to go show off some of the stuff we were working on last time with the custom matches and player counts. And I also want to go over one of the most difficult things you can do in multiplayer, which is state synchronization for when players disconnect and reconnect to the same server. So I want to do a little bit of a show of how we handle that, making some custom classes for that, and make sure everybody who rejoins or disconnects can come back and have a smooth experience. That's one of the biggest problems of a peer-to-peer game, is that right now, at least, there's no way for the server to not be another player. So if they disconnect, then yeah, everything has to reset. We're going to eventually figure out a way to do, if we've got time, a way to pass the server ownership over just to one of the other peers. So, but to start with, I'm going to go ahead and start the game up and show you guys what the new connection buttons look like for each mission. So start with this guy. I've just made a bunch of characters here. Selecting sandbox, create an online match, leave that guy up, and let me actually see. Okay, so we're getting both those windows. I'm going to go ahead and open up a couple clients. We'll open up 4. Select the next guy, and you see when I hit this button it refreshes, and so I bring down all the data that I need. I've got the mission name, which is coming down as an integer and being fed to that enum and giving the mission name. Steve is just the player name for everybody right now because I don't have a way to assign a player's unique name. Right now they come in as player plus a string of integers. So right now it's just all going to be Steve's. So I'm going to connect this guy, and you see these two have been brought in, but literally they've got fairly similar integers, so eventually we need to make an account system so everybody has a unique account. And you can see in this one, we now have 2 out of 4 players. We'll connect another guy. We'll run another client. And let's, it says 2 out of 4, so we were definitely missing an event there, so it looks like we did break something or some sort of cap here. I'm going to dig through the log. So it looks like he's got an add player with the correct account and another add player. So something in either the pull down or the add is broken, because that should be reading 3 out of 4. I'll have to dig in that, but we'll dig into that later. That's just dealing with the server and going back and forth is not the most interesting thing to look at. But I'm going to go show you what we got. And so all players load into this mission. There's no real data. Eventually, I'm going to be filling out the data here and letting you change missions in here and passing that back to the custom match. So when each player votes to start, all players voted to start, the match will begin and load you from the lobby into the game proper. Now everybody, there's only one spawn point in this test map here, so everybody just kind of moves in, and you can see they all kind of spawn in the same area. They've all got their unique characters. I've also got these little tracking widgets on or each player status widget, so you can tell what your ally's health is currently. Players can replicate their state of different equipment they have. You can see as they grab weapons, they will change the equipment and spawn new equipment on the ground near them. Certain events like attacks are all replicated across all these clients. I think the only owner of the server is the upper left. This is the actual master of the server. If he ends up closing his client, everybody will be booted from this game. But we'll eventually figure out a way to make that not the case. But just to show you guys, I want to show off how we handle state replication and how we handle loading back into a game and making sure you reconnect the game and having all of the state of all your characters, like their health, the weapon they're equipped, all load in correctly. And even if it doesn't load in immediately, it'll eventually get back into the right state. So the first one I want to show off is actually a kind of replication that we use. We use 3 kinds of replication, really. We use one called it's called a match replication. And so that's basically all it does is it replicates the information about the players in the match. So you can see all these characters have a unique avatar that they're using. And that avatar comes through their player data, which is a component of the match. And a match contains a mission. And the mission has its own replicated data. So if you look, I'm going to go ahead and just bust open this door. You'll see that even though this character is doing the attacks, the actual person who owns the state of these doors is the upper left, the owner of the server. So this guy will pass damage events to these things and they will be destroyed. Okay, so I'm going to show you just the basics is the basics of match or mission replication is pickups and items that are shared across all the clients. I'll show you what this looks like. So this guy can open a chest, it'll spawn items. So I'm going to go show you grabbing gold. You see that gold actually replicates to all the clients, you know, more or less immediately as he grabs it. Go ahead and grab some more here. And you'll see that everyone eventually gets the same value of gold. And there's just like that that gold value is replicated once, and that it's just lerping across to look a little cooler. So we've got this guy. He just did a bunch of stuff in the server. I'm going to go ahead and eject him from the game and bring him back. Okay, so I can still find the game here in the game list and join back in. You see what just happened there. He began with no items in his mission, or none of those collected mission items, and all the characters were spawned in and they kind of lerped to position. And that's kind of what we're talking about, is everybody comes in and is sending the correct variables about their state. Like you notice this guy with the apothecary hat here, he's got the swords and he's facing directly down. And so we're not, we're basically storing we're not really storing this information. These players are constantly sending this information to each other and to the server. And they get, in order to know to not send information, like you don't want them just to constantly be sending, oh, I have a sword equipped to everybody every frame, because then you'll just be overloading the network with messages you don't need. So the way that we handle this is when he sends a request, he sends these packets, they're basically UDP packets, and they don't require any kind of reliability. So they're just sending them because the reliable packets that you send require specific handshakes, and they make things, you know, quite basically means that it takes a lot longer for those packets to get through, and it has a bunch more traffic to the network. And so we don't do that. What he does is he tracks what when he sends this message out, he says, I have a sword, and he sends it to all the players. Those players will get that message, and when they do get the message, they send him back a handshake. And that handshake says, all right, it basically, you ask the player who you just sent the message to what weapon you have. And he should repeat back to you the sword you have. And as long as those two variables are the same, he does not need to send that handshake or that request to that player again. So he's constantly storing on his other clients that information. I think the easiest way to understand this as opposed to the characters is probably to do it through the missions. And I'll go through the missions variables because they're basically sent from the server owner to all players, and they add that handshake to them to make sure that the gold value or whatever we've got in the upper right is the same. And I'm just going to go really quickly show you how monsters replicate too. Grab some keys. You see those keys that I grabbed are actually they're actually also a mission replicated variable. And so when one person has the key, they all have the key. They can all open those doors. I'm going to go ahead and spawn a guy and bring him into this room. And you'll see... Come on, buddy. There's a trick I can bring him to drag him in if he doesn't come in willingly. The trick is just to hit him with the grapple and have him pull him towards you. So, this character is owned by the server. And so the server is doing all the AI logic for this guy's controls. He's beginning the attack. He's picking targets all on the server, and then every client is receiving information about this character. So let's see. And I'm just going to go ahead and kill this now, and I'm going to go ahead and show you the mission variables and how the rep notify or the rep var system I built works. So you see, I can close down each one of these guys. I think I built end is we'll pull them out. But if I end up closing the server owner, it will close. It'll actually eject all of them. So the other guy got pushed out. And I will go ahead and show you guys what my setup for this state replication looks like. Okay, so let's see. Probably the first thing I want to show is this class I built. And the class is called Replicated Property. Now this is all based off of what I know about the Unreal Engine's replicated properties. And to repeat, it's basically you have a property. The property has got a couple of definitions in it. It's got the type of property it is. It's got the bytes, because ultimately, when you're replicating something across the network, you're sending a byte array of to get to the client or the server or whatever you're sending. So this, and then I have the actual property object, which is this object here. Let's see. I'll go ahead and run through it. So here is, let's go through each one of these line by line. And so when a property is created, I send a type through, and this type is used in a bunch of areas to take a packet of bytes and turn it into the correct variable so that it can be used on the other end. And then I have this delegate that fires off from the child class. This replicated property has a couple of child classes. Like I said, there's a replicated actor property, a replicated map property, and a replicated mission property. And I'll go through the mission one real quick, and then I'll kind of explain just briefly how the actor one works. It's got another layer on top of it, because unlike mission properties, which are fairly global, an actor property is like the sword. You got to have a reference to the specific net actor who uses the sword, figure out what a replicated variable that is on him, and then kind of set the data for it on your client. So the biggest thing we do to track players is we keep track of players using our player manager. And player manager is pretty it's pretty basic. It all does is kind of track when players join your match and when players left your match. And this means even if you're for the purposes of mission, you're the server. So you only care if clients join or leave. Now, when it comes to actor properties, when you own the property as the owner of it, and you're posting it to other players, you'll need to know even if the player that joined is even if you joined a server. Let's see. So player joined, player left, and this is what we do. Just when a player joins, I have a dictionary that just tracks the player class and the byte array that is the property bytes of this thing. And so players join, you add this thing, you set it to null, because when a player first joins, he's not going to have any property set. You're going to want to send him and post him the data. And then if he leaves, you want to pull him out of the dictionary. Here is the function I use to change a property. It's just it's supposed to take in any value or any object, so like any typed, untyped object, and it does it takes that property and then it decodes it into the property bytes, which is just a byte array. So in the case of a Boolean, it actually just creates it's going to be a single byte there. This one's going to create a little byte array that's 1 byte as well. If it's going to be a short or a U short, it's going to convert it through here and set those bytes short. So most things that I send across the network are like, I'd say probably like 80-90% of the time is going to be a short or a U short, because it's a fairly large enough value that can kind of cover most variables, and it's only 2 bytes across. So let's see, and then when it changes a property, and this can be this is basically when the owner's, it doesn't matter actually, it doesn't matter if the owner property changes, it's still called on both sides. So here you change property, then it goes, all right, has the property changed? So if you set the property to the exact same value, the property hasn't changed. If it, and I'll show you what that looks like. And then it does this call property change, which basically just sends this event. And I'll show you how this thing is set up on like a mission class. Okay, so here's update property. This is basically what happens when someone receives the property or receives a property change, and it updates on like a remote client. Okay, here is replicate property. I have 2 versions of this. One just sends the GUID of the property, and that's basically like a unique ID of the owner of this. So all of my networking is actually done. Actually, let's see. This one is actually not used in missions. So mission over here, I don't use this. But all of the actors in my game, like the heroes, the doors, the chests, all have what I call a net actor. And I'll show you what this net actor is. And in order to know what actor is sending information across the network, or what actor needs to get information across the network, I have GUIDs, which is basically global unique IDs, and I have reserved different IDs for different object types. So even when somebody joins as a player, he's going to grab one of these reserved GUIDs. And if a GUID comes in with one between 1 and 4, I'm going to know that GUID is a player. And I reserve things like projectiles, which are things that will obviously spawn and despawn. They're actually cached as well. And then monsters, obstructions, and props. So each one of these has a unique GUID, and then it knows with this replicated property what GUID it's affecting, and then the index of because a single net actor can have multiple properties on it, and I need to know the index of those properties. So you have a big list of properties. It's similar to how Unreal has this this function that's like do replicated lifetime props on it, and it will kind of figure out which one it is based on the index. So every time we update a property, we have to send an index along as well, and the index is just a byte because I can't imagine having more than 250 or 6 different properties that are replicating at the same time. That would be way too many. So let's go through this. So these 2 are handled for actors, and this one is for missions. And so here's replicate property on this guy. This is what it does is it checks the player properties list, or this is actually the I probably shouldn't convert that to a list now I think about it. It takes the player properties. It's basically, like I said before, it's a player class and the current value of that player class's property, right? So it needs to know if the player it's iterating through all the players. It needs to know if the player you're about to send this thing to is not valid, or the value is already the same as its property bytes. So If the guy already has the information of the exact value you're about to send it to him, there's no need to send it to him again. He's sent you everything he needs, and the property hasn't changed recently, so you don't have to do anything to update it. And then so once you send this property, so let's show what this looks like. Go to the definition. So, like I said before in a previous video, all of my networking is actually just in two classes: packet sender and packet receiver. It's just an easy way for me to organize it without it digging and crawling through all sorts of different classes. And if I ever need to change my whatever I'm using to network, keeping it in two classes makes it a lot easier to move things over and know where the events are being called from. So this event's pretty simple. It sends to replicate, where's my mission property? It sends it to a target, and the target is always one of the players. Wait, why don't I open that guy up again? So it says it finds the player, which is the class for player here, sends it to that guy's network master, which is going to be his peer ID. Sends the index and the byte array, as you can see. So on the other end, the target here is unreliable. So even if this thing gets sent across, it will keep sending it until it gets a handshake from that client. So let me show you what that looks like on the other side. Okay, so here it is. Receive, replicate mission property. It finds, if the player gets it, it has to do some checks to make sure that there's a mission active. And, you know, I've got a couple of cases in here. If the mission's not been loaded, you know, you don't have to start updating things about that mission on that client until everything's been loaded. So it just kind of ignores packets when it's in a bad state. Then it grabs the sender. This is basically always going to be the server, because the server's sending the mission property across. Then it handles this mission property, and I'll show you what that looks like. Here is it's all in a nice, like, one little place here for me, all on a mission. So when it handles the mission property, it looks through whatever I've assigned for replicated variables at the index. Like I said before, it sends an index across over here to know what property it's replicating to. Because if you didn't have an index, it doesn't know if you end up having multiple properties, which you really should on a single object, you won't know which one to update. And things will get really strange. So go to this guy, and then it updates the property. And like I said earlier, this update property is, all it's doing is going into the replicated property, calling this class. Let's find that class, which is here. It takes the property bytes, assigns them, and then decodes the value into a value that you can grab later. So here is the new property. This, like, it's set as an object, but the property is going to be typed when we want to use it. Then it does this. It says, okay, I've updated the property at that index. Then I have to send this handshake back. I want to tell the person that just sent me the property, I got it, here is its value, you can stop sending me the property because I got the update. And here's the handshake. And the handshake's very similar. It just goes here, goes send replicate mission property handshake, sends it back to the target, which in this case is always the server, so there will always be one. And it sends this handshake, and I'll show you what the handshake looks like on the other end. And here's the receive mission property handshake. Make sure the mission is still valid, because the server can kill the mission while it's getting a received handshake. So we've got to do all the checks each one of these times. And that's the big thing about getting state replication right. You've got a million possibilities where things can fail, and you have to look for where those are going to fall apart and plug those leaks. Here we go, to handle the property handshake. Now, I still want the sender ID, because when I handle the property handshake on this thing, it finds the index, this is the one I sent out, and then it goes handle the handshake right on the replicated property. Go to definition. And here it is. Replicated mission property handles the handshake. And all it does is it says, all right, this player that I sent my property to gave me these bytes back. And these bytes I assigned his dictionary. Now, if you remember back, whenever it tries to replicate, it checks to see if this dictionary is equal to that player's property, or the current replicated variable's value. So it will stop sending it to him once he receives his handshake. So both of these things are sent unreliably. So both of them just keep posting and sending handshakes back at a set rate. And I'll show you what this looks like I had a mission open a second ago, of how this is set up and decoded on both the client and the server. Of course, I closed mission. There it is anyway. Okay. So here is a real basic. Actually, this is a mission state, and so my mission state enum is a replicated property. I'm gonna go figure out what these are. So these aren't particularly interesting to look at. Maybe I'll go into the standard mission because that one has the gold. We can actually look at those values because that we don't use that much actually at the moment. All right, so mission state. Oh, I gotta actually go to standard mission. Does it actually have it in base? Okay, let's grab this guy. Okay. Oh no, I don't even have it in here. Oh. Here is, okay, so here it is. It is in base. All right. Okay, so when a mission, let's go ahead and look at how missions are created. This is the constructor for the mission. It gets the data, decodes the data, sets all these variables for the mission. It loads the mission, and it loads the level. It goes through all these loading phases to make sure that the creature managers, the projectiles, the level comes in correctly, and it loops through these things. And at the end of this process, it should call mission loaded and calls base mission loaded, and I believe this one does two things. It defines my replicated properties, and whenever I call this function, I use the same name for this and actors, defining the replicated properties, and then it activates the replicated variable list. So I'll show what these two do right in here. So, define replicated properties. Like you saw earlier, there's a mission state property. I create a new rep var right here that says replicate. It's a new replicated mission property, and I type it. So, because it's an enum and there's only a couple of states in here, if you peek this guy, there's only like the mission loaded, unloaded, starting room, in game, all these. You only need so much data there, so just a byte. Then I set that mission state. So I can show you what this looks like. This is a getter and setter right here. What this does is locally, whenever I set mission state, actually whenever I get mission state, I go find my rep var if it exists. If it doesn't exist, I return it null or return it none, and then I get the property of it. I cast it to a byte, because that's the actual property that's coming out of this. This property is going to return an object. I've got to cast it to the byte, and then I cast it to an enum, and that will get me the correct enum. Whenever I set this mission state, I make sure I have the rep var, and then I change the property, and I send my value, whatever value I'm sending this thing, cast to a byte. So you can see that is actually calling right back into my replicated property. It's just like another layer on top, and I actually do it even another layer when I start talking about player stats, because they've got a couple more nuances in there. So changing the property from here will take its value and it'll decode it into a byte array. And then when I call a get, I will get the property. Let's find a get property, which will just return my property, which should just be my object. Doesn't want the byte array. It just wants the actual property typed, and then I cast it. So hopefully that makes sense. So it's defined it here. So it created a new class, and you only want to define things once, because you don't want to create multiple classes of these things as the level or mission unloads and loads. And I want to show you the clever way that I got it to start making a bunch more rep vars on component-like objects. So you can see here, the second thing that you do after the mission defines replicated properties is it activates the list. Now, I've been saying before that every rep var sends out an index, and that's why we have this list here, because it's going to send that index out, and then when it receives a thing with that index, it'll know which object in the list to update. And let's go ahead and show you what this does here. So whenever I have my activated list, I'm not just replicating the things in this class. I'm actually getting the components on this class. And as you can see let's find, I think it was in mission. Mission, I've got a couple of extra components that sit on mission. And they do different things. So the mission itself, the class for the mission does loads the mission, unloads the mission. But I have a bunch of different behaviors that I want to, be different per mission. Or maybe they're shared, but maybe they've got very specific uses. I don't want to bloat this class with a bunch of information, and I don't want to make a massive mission class that I have to constantly look through. So I've got 4 classes right now. I've been adding more as it goes. The death behavior kind of determines what happens when a monster dies and when a player dies. The item behavior is the one we're going to look at, because this one tells us what kind of loot will drop. It's actually a loot drop class. Let's keep it over here. Okay, so here is my mission component. It's a reference, just like most classes in Godot, and it's got a bunch of rep vars in it. You can see that I've got mission item state, and mission item state is a class that basically tracks the keys. When I say mission items, it's like keys that will unlock stuff. So that's what this does. But the ones I want to talk about is just gold. Here's gold. I've got lore. I've got relics, which is the books and the little onks. We'll just look at gold. In this class, so item behavior is created over here. Let's see where I set it. I set it right in... I don't know where I set it. I probably set it somewhere in missions, I imagine. Oh, here we go. Yeah, when the mission is loaded fully, I create these classes. They will be overrideable, and we'll probably have different, inheritance on these guys once we get further along. So it creates all these things, and then it defines a rep var list, a replicated properties list for me, and then it activates them. But each one of these, when they're created, they have their own property to define their replicated properties list. So what does that mean? That means that I have a set of replicated properties that are ready to go and replicate across the network on this class. But I do not activate them on this class. I only activate them on my mission class in this big list here. I will find my mission item behavior, I will get its rep var and add it to my rep var list. That way, it's very similar to how Unreal works, where a component actually lists for an actor to store all of its replicated properties and send them across the network. Because the component won't replicate on its own; it needs an actor in order to send them over. So this is pretty similar to how that works. It also means that when I want to update a mission, it's all updating in the same location, and all updates at the same rate or whatever rate I want this thing to replicate at. And I don't have to keep tracking each one of these components and its replication rate, which is just cleaner in my brain. Now, all of these guys here have that property defined. It sets the value. They've got getters and setters here, which are basically the ones you've seen everywhere else. This pattern is pretty basic for mission items and mission variables. It gets a little more complicated when it gets into actor properties, and I'll go through. I may go through some of those if it's easy to do. But yeah, so all of this is running on the server, collecting currency, collecting runes. All comes in from the server. So even though a player looks like he runs over some gold and picks it up, the server's actually listening on that gold, and it's waiting for that pickup event. And then the player will get all the events that come down from it, including the replicated variables. Okay, so I've defined the variables and I've activated the list. All that activating the list does, it adds them to a list of things that when I eventually want to send this list across the network, I think it's in mission here. Do lifetime replicated props. This is what I got here. This is where it finally takes my activated list of rep bars and it replicates the property. And so it goes through down the list. Each property gets replicated across the network. Now you're probably wondering, okay, what rate does this go out at? And I'll show you let me see where I set this. I think I set this right in the mission manager, because this mission is a reference, so it can't actually add a timer to it. So here's my mission manager. And what this does is it's kind of like a container class that handles, it's kind of like a static class that handles different events for the mission, sets what your current mission is, gets some getters, and it just has a bunch of listeners for things that players would want to bind to before a mission exists, if that makes sense. And it also does things like handles mission processing. So here we go. Here is my broadcast timer. I've set one up here, and I set that missions broadcast every 10th of a second, that's fast, but even though it's shooting that timer off every 10th of a second, it's not sending data at that rate. It definitely isn't. Once it gets the first handshake for any of that data and it hasn't changed, it'll stop sending messages across. So it can be fast. I think some of the properties I have replicate it I think most of my movement replicates at about 5 times a second. So this is fine for now. I haven't done any testing on how much bandwidth I'm sending out, but it's not very much from what I've seen on the profiler. Let's see. We've got this broadcast timer. We've got connecting this timer to broadcast. And all I do with broadcast is get if the current mission is null, or the current mission is not my local authority, which means I am not the owner of the mission. Like, say I was the owner and we figured out a way to make it so that somebody else became the owner, or we passed it, then don't do any work. And then this is just calling that lifetime replicated props, and it sends them all across, and it would go through each one of these rep bars and send that thing across the network. And so you're looking at mission item state, I believe, is a byte. I think these are all, this is a byte, this is a short, this is an int. So yes, you can get a lot of runes. So that's going to be 3 bytes. Gold is an int as well. Lore is an int. So we're sending ints across. Probably doesn't need to be that big, but it's not that big of a deal. So ultimately, when it sends them across, U short, it caps at 50,000 or 65,000. Probably could be a uint because we don't really send negative values across. So it'll send, when it's sending replicating the property, it'll send a byte, which will be 1 here for the index, and then it'll send 3. So each one of these mission properties is basically 4 bytes across the network, plus whatever Godot adds to the front and back of the packet. And it's always unreliable, which means it's not waiting for anything. It's just going to send them until it gets the handshake. And that guarantees, waiting on the handshake, that it'll eventually get the value and stop sending that across to that target. Now, that's the big thing about making sure that players leaving is pulled out of the replicated property, because you don't want to send it to somebody who doesn't exist. And you don't want to wait for a handshake to somebody who doesn't exist. But I've got all sorts of checks in here to stop that. Okay. Let me see. On my list of things to do, I've got a lot of things that mostly involve getting lobby info updated, and those are not the most interesting to look at. But what I can do instead is I've got a couple things I need to do with my my vertical slice mission. Now, let me show you what I've got here with the current implementation. I built a couple of test missions, which are just kind of proof of concept for various things. I got my sandbox, which is that when you're seeing where people move in and they can get all the weapons. Vertical slice is a mission that's supposed to be as close to how the AI is that I want and how the flow of a mission will be, that ultimately when I'm doing like a full launch, that will be kind of the mission. And I've got this survival mode, which is just testing a bunch of monsters and trying to get the cap of it. I also have this boss room, which will spawn a single mob, and then basically does some modifications to convert him to a boss, and then repeats the process, just so I can have that boss encounter, because the vertical slice will have certain elements and certain events that will pop up that will spawn a boss and force players into that to stay in that place. So let me show you. I'll show you what vertical slice. I want to turn this off actually. Let me go change my spawn point manager. So I believe I turned it on so that the only thing that spawns is those spear guys. So I'm going to go and turn that off and show you what a vertical slice is going to look like. And then I'll show you all the stuff I need to do to hook it up with the closer to the AI that I want. I'll just play a solo, which is offline. Okay, so here's like a starting room. The group will be starting in this room, and at this point, the mission is in a state where there's no monster spawning. AI director is kind of shut down, similar to how you'd see it in Left 4 Dead, where you can kind of get your weapons ready, get ready to go, maybe do some communication, and then you can enter once you open one of these doors, the mission will begin in the AI director. So this room's, again, a lot of these rooms that I built are fairly testy, so like there'll be rooms with a million monsters spawning just randomly. So this is the general layout of a level. The levels are essentially going to be close to like a city street, where you'll have these paths going between different buildings and doors and things to explore that will open up into rooms, and most of the time spawn a monster in that room. And the way that it works right now is every time I built a custom level editor in Godot, just using its tile map and a couple of like custom tile stuff. Nothing you'll actually see in the level, but things that just help me lay out scripting elements on the tile map. And then that is read to spawn these monsters at specific times. And they've each got unique spawners, and they kind of know how many times they're allowed to spawn at something and track where they were. But other than that, there's not a whole lot to them right now. And what I want to do is I want to kind of make it closer to what Left 4 Dead does with its monsters. I want the street areas to have spawners that repeat, and indoor areas have spawners that just shoot off once, so that you can do an exploration, find some cool stuff, break into a building, and then kind of move on. So you see, I can kind of spot some of these areas. This level is somewhat randomized. There's a seed that goes into it, and it does the layout of the level and with a couple parameters, and then it also does modifications to the level based on a seed as well. So you'll notice that if this area that's covered in boxes right now, if we were to play this again, that the odds that there'd be boxes there in the same exact pattern is going to be different. I will break open the level editor and show you what that looks like. I'm going to try and roll through this stuff. I'm not killing anybody, just want to run you through the basics. You'll see that the big goal of this vertical slice is to get players to get into the central courtyard of the map and fight a boss, and that's how they leave the level and complete the mission. But in order to do that, they have to go find a entrance or a green key. And I should have showed you that green area, but just take my word for it. There's a green door that prevents you from getting in there, and you'll see that there are blue doors like all over the place I can't open because I don't have the blue key. Some dudes here, and then so I've got to find the blue key first, and then I can get passed to a second area that will get me the green key. There you go, there's the blue key. And the location of the key changes based off of the seed as well, so when players come into the level, I want them to, even though they're playing the same mission, I want to make sure that it's more replayable by just making sure that the level keeps mixing it up. And obviously these monsters are going to be mixed up too. It's not going to be, just a random number of monsters. We'll have to figure out a way to build a fairly decent AI director that can kind of handle what the player's status is, if they're hurt, if they need to turn the pressure up on them. And the biggest problem I've got is none of my AI right now do any kind of pathfinding. And I was looking into just doing a typical A-star for them because of the world's tiles, but I think I want to even make it even lighter weight than that and probably just use doorways, because they work fine for the most part around boxes. The other way I could do it is I could just ensure that they attack when they see a box in front of them and they've got nowhere to go. So okay, so I got the blue key. I can open up blue doors, and there's two tiles in this tile set that are actually specifically always blue doors that are the only way to get through. So you actually can't pass this tile unless you have the blue key. And that means I can have the AI know to put the green key behind the blue key doors. So the green key is actually in the tile to the north of it, if I remember correctly. So it should be in here. Here it is. And then it's got some blue doors in here. These weapons that spawn are semi-random. One of the things that I did not add to this level yet are the chests, and I'd really like to go start adding those chests back to this level. I know I went over this last time, but you do have level ups and upgrades. I'll go ahead and just add a couple as I level up here. See if I can get a better weapon. There should be something in one of these doors that's better than what I got. I already have that. It's not going to be useful. And you see these potions on the ground. I've since kind of changed my mind on how I want to handle the healing. I think it's going to be much more bandage-based, where you have much less of it, to make it a little more roguelike. But, I've got to balance that with players being, officially knocked out, and that's the tough part, is you want to play with your buddies, and you want to make sure everybody's still alive, but you also want some sort of pressure there. And so I've grabbed the green key and the blue key, and here is the entrance to the green doors. And this is the central, and you'll notice this is just the tiles I use for the boss room. So ultimately, you'll come in here and there'll be a boss you'll have to fight, and that will begin the mission end sequence. So let me just pretend this guy who wandered in here is my boss. Take him out, and this is a tile I built that's just a warp tile to get you to the level, and it should give you mission end. Yeah. Obviously, not the best menu, and it brings you back. So I've got the full loop of everything loading and unloading. But what I want to do is I want to go ahead and do some changes. I want to make a couple of features in here. I want to change how the spawning tile, or change some of the scripting on the level. And then I want to add chests. And what I really want to do is I want to make a kind of tile that requires the team to get together. I want to call it like a gather party tile. And that tile will make players have to go to the same spot in order to advance. Because we don't want players necessarily to spread out so much that they're just running in different directions. Because what's great is if we can make that tile be something that brings the party together, I can do something like lock all the doors around them and have them forced to fight an encounter. Because, as you can probably tell, like right now, running is pretty optimal. Don't have to really fight much, and I want to have a couple of locations where a force of a fight is important. Let me go ahead and show you what it looks like when I've got these tiles. So all my tiles are, I call them chunks, and they're 30 by 30 tile map. Here's the one you start in. I'll go ahead and show you what all this stuff looks like. And again, when you're in game, none of these things are tiles. These are actually objects that are placed and spawn at the location of where they're located on these tile maps. So here is the player start location. Let me turn off the variants. So when the seed comes in and decides which one to pick, it goes through these lists, and it finds the variant it wants to use. So right now I've got basically, you see this is this 0 index is the room, 1 index is also the room. So basically, let me just close these off and I can show you what it looks like. So room 1 is this guy, and this is the one you saw when you first loaded in when we were just playing. And it's got these 2 locations here. It's also got a scripting map to it. And here is the scripting map. It actually has, it's a different kind of tile map that I use to create triggers and volumes and things that change, that will actually spawn monsters. I think I got monster spawners in here. There's a proximity triggers that I've set up. And again, once the level loads, it starts to go through this tile map and reads these triggers. And it kind of decodes them and figures out what it's supposed to do with them. So the real quick way I did it is proximity trigger A will trigger anything that's useful under A. And basically right now the thing I've got is a kind of monster spawner. So whenever A is triggered, it'll look for all the monster single or monster A related tiles, and it will activate those spawners. I got a boss one. Let me just show you some more stuff. So that's room 1, and that's the upper left. Room 2 here, or room 0 and room 1. So here's room 2. And you see, I've got, this is what we saw when we first moved to the right, which was visible triggers. And what that means is whenever this tile becomes visible, and what that really means is I have a door in there. When the door is destroyed or opened, this thing becomes visible and triggers all the related A-type events. And you can see there's one down here as well. So if I were to come in from the other side, it would trigger all of these spawners because it's related to A. Let's see. Let's go to room 2. Room 2 looks like it's this and a little bit of the outside. I've got torches placed. I've got these proximities, and then we got the same thing here. Whenever that door is opened, monster. These are this is the problem. I have a couple of repeating ones. So I've got monster spawn singles, mean one monster will spawn from that location, and then it will be done. It won't spawn anymore. Monster repeating mean this thing turns on, it kind of stays on. And I want to get rid of those. And I want to make sure that there are monster repeatings on the outside that just stay on all the time, and I can use the AI director to loop through them and figure out where I'm going to spawn the monsters. You want to spawn them sort of near the players, but you probably want to keep them from spawning directly on top of the players. And it looks like I didn't get the chest hooked up, so but I have placed them in some areas, which is good, because I definitely want to go through and hook these guys up with real chests. Let me see what it looks like. So, I'm just going to go into this guy and do some painting. Here is my markup map. This markup map contains a bunch of elements, like probably hundreds. And that's going to represent all of the obstructions and props that I want to spawn in real time. And it looks like this chest might be the correct chest. I'm not even sure if I've set these up properly, but you can clear stuff. I can add different... get rid of this guy. If I wanted to, I could put the key right there and run the game that way. But again, this tile map is never seen by any of the players. It's always defaulted off, never renders. It's just specifically for when you spawn in, when the level loads, it reads this and spawns the correct obstructions and monsters there. So this other map, I want to go ahead and change this so you can see if I were to like put some stuff here. Let's see which one I get. So in the top one, it's gonna pick one of these two when I load in next. It's gonna pick variant 2, room 2's variant 1, or room 2's variant 2. Let's see which one it gives me. And I think I got rid of all these coins. These coins don't exist because I changed them over to the cool gold coins. So I'm gonna go ahead and run that. Vertical slice. Oh, something weird happened. It didn't. It's occasionally. I actually want to see what that log said. Occasionally, something happens between one of the visual. I think it's doing something weird where it might. I use a thread to spawn a lighting manager, and I think it sometimes craps out of me. So. Vertical slice, but not every time, which is kind of weird. Oh, it crapped out again. Let's see, hold on, let's take a look. There may be actually a problem there. Okay, so loaded the prop manager, no problem. Loaded all the actor managers. Loaded the visibility manager. Process manager loaded. Loaded the lighting manager, so it loaded all the process managers. And it loading. Scripting manager loaded, so it did those. Mission loaded. It got really far in. Match loaded was the last one it did. That's interesting. So maybe there's something, like if there's usually a problem, it's probably in my second thread. Or maybe something in that is failing silently because I can't load it properly. Okay, so it loaded that time. So that's something I've got to look into. There's a demon in the scene loader. Okay, hey, I got a chest. So yeah, I just have replaced that locked chest with the real one, and here we go. We got that chest again. So I have to populate those in the world. And of course, because if you remember, this one was a repeated monster spawner. Monsters will just keep spawning out of that, and you can't do anything to stop them. And I don't like that. I want to make sure repeated ones are more controlled by the AI and kind of keep up the pressure on players without just overwhelming them with a million guys spawning at them. So that is my big task I want to get on my plate and finish. So it looks like what are we at? We're about an hour in. So I think we're going to call it. I'm going to start, get back working on this stuff. If anybody has any questions about how I handle any more mission-related stuff or any other application stuff, just throw them down in the comments. All right, see you guys next time.